Okay.
All right, our aim today is going to be trigonometric graphs. How do we graph a sine wave? How do we graph a cosine wave? How many of us remember our unit circle? Oh, awesome. Great. Love it. But for your viewing pleasure, I am, one of the students is handing out the unit circle. Okay? And with that, we're going to have some paperwork that I want you to use. I need somebody else to hand this out. There you go. And one more. And we're going to hand this out. Oh! There. Okay, so the aim is to define trigonometric functions using the unit circle, and using the unit circle, derive the sine and cosine graph. Well, let's begin. First, let's remember what we've done so far. Okay, the sine function. What is the sine function in terms of theta?
It's the opposite angle over the hypotenuse.
Opposite over hypotenuse. So when we're looking at the unit circle, we have opposite over the hypotenuse. Now, when we're dealing with sine of theta, the position is where the watt of the angle intersects with the unit circle. What do we call this right here? This line. We have the initial side and then we have the terminal side. Good. Alright, so we have the terminal side. Now, when we're dealing with the unit circle, which part of the unit circle as far as the coordinates is the sine function? Is it my x or my y value? The y value. Okay, so when we're dealing with that, we have, okay, let's skip this one. Okay, so here's our unit circle. So we're dealing with the y value. So if I'm looking at the sine of 30, what's my exact value? 1/2. So if you look at that second sheet where you see the y equals sine of x, on the second sheet, you have the reference, you have a terminal angle. So if you see the graph of sine of x, you're going to see on the second page, right, you're going to have a table. So what I'd like you to do right now, and you can do this in pairs, is I want you to fill out the reference angle, the exact value, and the decimal value. Okay, so let's do the first one together. So the sine of 0, what's my reference angle? 0. What's my exact value? 0. And what's my decimal value? 0. How easy was that? Okay, so sine of pi over 6. Okay, so what's my reference angle for pi over 6? 30. So then what is my exact value? 1/2. And my decimal value? There you go. So what I'd like you to do, if you want to work in groups, that's great. Fill out the rest of that table, and then we're going to move on and then graph the function based on this. Okay? So what we have is the unit circle, and we have the table that we want to fill in. Then I'm going to ask for a volunteer to come up and put the information up on the smartboard.
Oh, like that. Like,
Oh, yeah. Yeah.
Oh, okay.
Okay. Does any cups?
Oh, yeah.
I'll be right now.
But if you want to go sing out,
I got it.
are you going to finish all of that?
Yeah. I'm ready.
You ready? Go. You're welcome. There we go. Since we're working in pairs, maybe we can share caps because it doesn't seem to be enough. Thank you. You guys got these together? Or? Okay. Awesome. Do you have one? Okay. Do you need one? You share? Okay. Everybody's good? Awesome.
I like the little colors.
Then once we've filled this out and we've graphed it, we're going to answer the questions that are on page 1. No, I'm finished. Okay. You want to do me a favor? Write down the reference angle and the exact value. Put that up on the no? Okay. Yes. You notice a pattern over here? Yeah. So you don't even have to look at the unit circle anymore. As we're going through this, anybody notice anything? Yeah, just the sign changes. And what else do you notice about it? You see any kind of pattern? What kind of pattern do you see?
Oh, they switch. It starts from like half and
Okay, so it's going up,
yeah, it goes down.
then it's going back down,
Then it goes back up.
then it's going back down,
Go down.
and then it's going to go back up. So once we plot it, we'll understand why it does that. Okay, you ready to put it up?
Yeah.
All right, come on down. I feel like Price is Right. Monty Python. Is it Bob? Bob Parker? Who was the Monty guy? There was a guy Monty. I know.
Oh, you got my deal.
Let's make a deal. I knew I remembered the show. Okay, so as we're putting up the information up on the smartboard, I have a few questions for you. With regard to sine waves, what are they good for? What are they good for? Where do we use them? All right, how many people charge up their phones? Oh, we all use, electric. We got to plug it in. Guess what? That's sine wave. Anybody hear about, in Bellport, they just installed these new gun detectors, gunshot detectors? Anybody hear about that? Oh, okay. So in Bellport, they just putting it within the town, these gunshot detectors. What it does, it can tell where a gunshot came from, okay, where the location is, and whether or not it's a real gunshot. Because you want to be able to differentiate between a gunshot and a car backfiring or a firecracker, especially on the 4th of July, right? You know, otherwise you're going to have a lot of gunshots out there. Well, the gunshots have a special signature, okay? And that's made of a sine wave. It has a different frequency, okay, than any other things. How about, how many people sing? Sing? Play instruments? All right, we got some instrument players, okay? All right, guess what? You have to tune up your instruments, right? Hey, tuning is a sine wave. Harmonics is a sine wave. So just think, without sine waves, you wouldn't have electricity. That would be a problem. Yeah. How about music besides instruments? How many people listen to the radio? Okay, what station do you listen to? 105.1. 105.1 what? 105.1 megahertz. What is mega? Huh? What is meg in science? To what power? To the 6th power. Okay? 10 to the 6th. What is that in regular notation? 1 million. Okay? Sine waves are measured in hertz. So 105.1 megahertz. You have 105.1 million cycles of a sine wave that's going through the air in order for you to hear it out of a radio. Sound waves. How many people go fishing? Anybody go fishing? Okay, we got a fisher. We got 1 or 2 fishing. Okay. You got to look at the tides, right? So see high tide, low tide. If you were to make those measurements, sine waves. So okay, so now we couldn't fish. We couldn't put our radios on. We can't plug in our phones to charge if we didn't have sine waves. So, gotta love the sine wave. Yeah. Love the sine wave. Okay, so once we have all the data of the sine wave, now what we're going to do is on the first page, you are going to graph it. You're going to graph those points that we just put down. Okay, so when we measured, we go back to our graph at pi over 4 on a, what was the value? What was the value for pi over 4? At 45 degrees. What was the value of sine wave? 1 over radical 2. What was my decimal value? 0.707. Look at your graph. What kind of, what do you see as far as the differences? You got 0.6,